This session is a continuation of the Chapter 3 review, starting with Problem 17. Problem 17 and 18, we are told use the graph at right to find the slope of the given line. So here we have line C, and we have 2 points on line C, and we're trying to find the slope. So over here, let's go ahead and say 17 slope. We have y2 minus y1 over x2 minus x1. We'll use this one as 2, this one as 1. So y2 is 6 minus 3 over negative 4 minus negative 4 minus negative 4. 6 minus 3 is 3. Negative 4 minus a negative 4 is simply negative 4 plus 4, which gives us 0. As we've learned in the past, we can't divide by 0 because 0 goes into 3 an infinite number of times, and so this is undefined. Okay, now for line D in number 18. Line D, we have 2 points here. We have 0, 4 and negative 4, 3. So using the same slope equation for 18, we have 4. I'm going to use this as 2, this as 1. Minus 3, 4 minus 3 over the x's, 0 minus negative 4. 0 minus negative 4. 4 minus 3 is 1. 0 minus a negative 4 is plus 4. So our slope for D is 1/4. And you can see rise of 1, run of 1, 2, 3, 4. Back on this line, line C, we can see that we have a rise but no run. So that's why it has an undefined slope. And just for completion, we can see that in line A, it has a run but no rise. So this has a 0 slope, and this has a negative slope. So now on to problem 19. In problem 19 and 20, we have more of the same. This time we have no pictures. We just have coordinates. So the slope between these two lines for 19, we will have, let's call this point 2 and point 1. So the difference of the y's, 13 minus 3, over the difference in the x's, 1 minus negative 1. I always like to use the parentheses because it keeps us from making silly sign errors. 13 minus 3 is 10, and 1 minus negative 1 is 2. This simplifies to 5. So this line has a slope of 5. Going to number 20, y2, negative 7, minus negative 1, divided by 6 minus negative 4. Negative 7 minus negative 1 is negative 7 plus 1, so that's negative 6. 6 minus a negative 4 is 6 plus 4, which is 8. This gives us negative 3/4 slope. And now on to problem 21. In problem 21, we want to write an equation of the line passing through the given point that is parallel to the given line. So here's our point, 2, 0, and the line is y equals 3x minus 5. We've learned in this chapter that parallel lines have equal slopes, and so the slope of this line is simply 3. That's the only purpose for this equation, is just for us to get the slope. Everything else is of no value. We're going to have to calculate our y-intercept on our own. So we're going to use the slope of 3, and we're going to do this in two ways. First way, we will do the point slope form. Point slope form is y minus y1 equals m, the slope, times x minus x1. So with a point and a slope, we have y minus our y1 is 0 equals our slope is 3 times x minus our x1, which is 2. Now, in this form, we have the equation of a line. It just happens to be in point slope form. Let's go ahead and simplify this. Y equals 3 times x minus 2. If we wanted this in slope-intercept form, we would just distribute the 3. Y equals 3x minus 6. And there's our equation in slope-intercept form. Now let's work the same equation, but this time we'll use the slope-intercept form to find our equation. So slope-intercept form is y equals mx, that's an m, plus b. Slope, intercept. So again, we know our slope. We have our y, we have our x. We're just going to be looking for our b. So our y is 0 equals our slope, which is 3, times our x value, which is 2, plus b. The whole purpose of this is to find our y-intercept so that we can back substitute. So 0 equals 6 plus b. Subtract the 6, negative 6 equals b. Now we're going to substitute back in. We're going to put this 6 in for b, and this slope in for m, and we're going to rewrite down here. So y equals 3x minus 6. Substituting the 3 for m, 3x, negative 6 for b. And we can see that the answers match. And now on to problem 22. In problem 22, we have a slope of 1/3. So y minus y1 equals m x minus x1. So y minus, our y this time is 1, so minus 1 equals m is 1/3 x minus our x value, 3. So that's y plus 1 equals, let's distribute this 1/3. 1/3 x minus 1. 1/3 times 3 is just 1. 1/3 times 3 over 1. When you multiply fractions, multiply the numerators and then the denominators. So we get 3 over 3, which is 1. So here we have it. Now, let's simplify this. Y equals 1/3 x plus, whoops, it's actually minus 2. And now let's do the same equation using slope-intercept form. So y equals mx plus b. Our y again, -1. Our slope, 1/3. And our x is 3. Plus b. Again, 1/3 times 3 is just 1. So -1 equals 1 plus b. Subtract the 1, -2 equals b. Back substituting what we have, y equals 1/3 x minus 2. And the equations match. And now on to problem 23. In problem 23 and 24, we're looking for lines perpendicular to a given line. So write an equation of a line passing through the given point perpendicular to the given line. So here is our slope, and the slopes of lines perpendicular to lines are the negative reciprocals. So for 23, if our first slope is -2, our actual slope is going to be 1/2, because -2 is -2 over 1. When we flip it, we have -1 over 2, change the sign, it's 1/2. So this is our target slope. So y minus y1 equals mx minus x1, y minus a -1 is y plus 1 equals our slope 1/2 x minus 6. And simplifying, y plus 1 equals, distribute the 1/2. 1/2 times 6 is -3. Subtracting the 1, y equals 1/2 x minus 4. And now for slope-intercept, y equals mx plus b. Our y again is -1 equals 1/2 our slope. X is 6 plus b. -1 equals 1/2 times 6 is 3 plus b. Subtract the 3, -4 equals b. Substituting these back into this equation, y equals 1/2 x minus 4. And they match. Now on to problem 24.